Hi, everyone, and welcome to the third and final session of our Building an Ethical Algorithmic World series. We're thrilled that you're able to join us today. My name is Jocelyn, and I'm the research facilitator for DFP, and I'm happy to be a part of the JEDI Health Cluster Alliance. Before we begin, I'd like to acknowledge that UBC, including the classrooms and offices used by the JEDI clusters, is located on the traditional, ancestral, and unceded territory of the Musqueam people. Just to break down some of these definitions, the traditional recognizes lands traditionally used and or occupied by the Musqueam people or other First Nations in other parts of the country. Ancestral recognizes land that is handed down from generation to generation. Unceded refers to land that was not turned over to the Crown or government by a treaty or other agreement. I encourage you to learn more about this using the links at the bottom of this slide, and specifically take a look at the map of native land to see what land you live, work, and play on. At this point, I'd love if everyone could introduce themselves in the chat, and if you're able to, maybe tell us what land you're visiting us from today. And while everyone's introducing themselves in the chat, I'd like to take a moment to introduce the group organizing this event. We call ourselves the JEDI Health Cluster Alliance, with JEDI being an acronym for Justice, Equity, Diversity, and Inclusion. Our group was formed earlier this year by the admins and coordinators of several research clusters at UBC. We started regularly meeting to talk about issues of gender, race, and diversity at UBC and in academia in general. Eventually, we decided to form our group and to pool our efforts, organizing workshops and events to improve the JEDI skills of our research community through education, practice, and implementation. We currently have 7 core partners: Women's Health Research Cluster, Designing for People, Biomedical Imaging and Artificial Intelligence, Center for Artificial Intelligence Decision Making and Action, Data Science and Health, Regenerative Medicine Cluster, Dynamic Brain Circuits. And we have 3 affiliate partners: Action on Sepsis, Diabetes BC, and Blockchain at UBC. So if you would like to join us, we'd love to have you. Please just give us an email. Today, you'll be hearing from a panel of algorithm experts led by our moderator, Azim, Associate Professor of Psychology at UBC. Dr. Azim is a social psychologist whose research focuses on where morality intersects with religion, cultural attitudes, and economics. More recently, Azim has been looking at human-technology interactions and the ethics of automation, including self-driving cars. Azim, thank you so much for agreeing to moderate today's panel. And at this point, I'll turn things over to you.
All right, thank you so much, Jocelyn. And thanks everybody for attending. This is the third part in a 3-part series that the JEDI Alliance has been doing on building an ethical algorithmic world. So the first part was a screening of the hit Netflix documentary Coded Bias. The second part was a Q&A with the director of that, Shalini Kantaya. And now we have this wonderful panel. For those who have or have not seen Coded Bias, I am going to be picking up on some of the themes from that documentary, but I'm also going to weave it into the expertise of this very impressive panel of experts that we have. So you don't need to have watched the movie. We'll be fine with that. Let me introduce those panelists. So first, there's Aline Talhouk, who is an assistant professor in the Department of Obstetrics and Gynecology in the Faculty of Medicine, though she is a statistician by training, working in machine learning, I believe. She's also the director of the Data Science and Informatics at OVCARE, which is BC's Ovarian and Gynecological Cancer Research Program. And she completed her PhD here at UBC, as did I. I think I did it before you. All right, then we may or may not at this point have Blaise Agüera Arcas. I don't think he's here yet, so let's just skip his introduction for now. If he shows up, we can reintroduce him. Mijung Park, another UBC colleague, is an assistant professor in the computer science department. She specializes in privacy-preserving machine learning, and she's also a Canada CIFAR AI chair. Welcome, Mijung. Dr. Marc-Antoine Dilhac, hope I'm pronouncing that correctly. He's also a CIFAR AI chair, in particular in AI ethics, and he's a professor of philosophy from the University of Montreal. And there is Blaise. So thank you for joining us. Blaise is our resident non-academic. So he's a vice president, fellow, and distinguished scientist at Google Research, where he focuses on machine intelligence, but he seems to occupy more of a sort of a polymath role there, and is also a frequent TED talker. All right, so before I jump into these questions, from what I understand, we have a pretty sophisticated audience here and a very sophisticated set of panelists who have deep technical knowledge, much more than I have. So panelists, feel free to answer at a pretty high level here, and I will try to keep up. I think everybody else will be able to keep up, and I'll do my best. I want to start with Dr. Dilhac as a way of just getting us started into the general issue of algorithmic harm and bias. So in Coded Bias, we have the director, Shalini Kantaya, who in another interview said she somewhat regrets calling the film Coded Bias because it focuses on a much larger topic of general harm that algorithms can do. This is something, Dr. Dilhac, that you've written a lot about, how technology are challenging existing political structures and potentially corrupting our democracy. So I wanted to ask you, where do you see the biggest societal dangers being perpetrated by our expanding use of algorithms today and in the future?
Well, thank you for your invitation and for this very difficult question, because it covers a wide range of issues with algorithms. But first of all, I just would like to recall that AI is a terrific tool that performs amazing tasks that we didn't dare imagine a century or even 50 years ago. Well, I think that if AI was only a bad thing, we wouldn't be here to discuss it. I just want to start with this in mind, because it's sometimes it's one-sided criticism against AI and technology. Now, to answer your question, I would like to go back a little bit in time. It's my philosopher bias. The rise of algorithm and of mechanization of thought is part of a long history. And among philosophers, we agree that it started 3 centuries ago, maybe in the 17th century, with philosophers like Thomas Hobbes and Leibniz. In fact, I would say it's even older than that, and maybe goes back to antiquity, when people started to use, tools such as abacuses to make calculation, and when they develop algorithms, it wasn't called algorithm at this time, but kind of algorithms to settle problems such as how many ties do we need to cover a surface. Okay, so it goes back a long time ago, and the key idea with algorithms is that it's a procedure that helps us solve problems, and also, and this is the thing I would like to highlight today, it's a procedure that could think for us, okay? Leibniz, for instance, called this blind thinking, caeca cognitio in Latin. And this is where the problems begin, which the development of AI, machine learning, amplifies to an unprecedented level. And what is the problem? Well, basically, we reduce thinking to procedures and delegate active thinking to objects, artifacts, machines. So machines are very convenient and even very reliable when you need to perform difficult calculations, computations. For instance, sorts medical cases by emergency priority, okay? But when it comes to making decisions in complex social situations, complex social environments, well, relying on machines is much more problematic. And the consequence, I think, is very obvious. With machines and algorithms deployed in the public sphere, well, actually, we are losing control of our lives, our social and political environments, and eventually, machines kind of steer or run society. Okay, so this is the major danger at this abstract level. More specifically, I could think of 4 widespread practices or applications that are really problematic and pose the greatest risks to society as a whole. And I'm not going into details, but I just want to list them. The first one is social scoring. And it's not only, you know, the most discussed system implemented or rolled out by the Chinese government, but scoring by insurance companies, banks, social networks, etc. It's very well described in the documentary, by the way. The second one is predictive policing and justice. And the idea is very simple. Algorithms can help us predict risks of committing a crime or risk of reoffending. So it's very useful to, you know, to manage social risks. The third one is micro-targeting. So it's a very, I mean, a great threat to democracy. And not only to democracy, but I think to our psychological integrity. So micro-targeting is not only about political systems, but it's all kind of micro-targeting systems which manipulates feelings and emotions and preferences and turn individual into predictable machines. And the fourth one, obvious, it's surveillance, which is, well, the paradox is it's both the result of those practices and their precondition. Okay, so it's at both ends of the system. Yeah, I will end there. I think those 4 practices and applications are great threats to our social life.
Okay, that's great. I think we're going to pick up on all 4 of those in our discussion now. And I really do appreciate you kind of framing the trade-offs we have between the benefits and the risks and harms here, because I think that's something that we all have to keep in mind. To that end, and picking up on the last issue that you brought up, it seems like one of these big challenges is how we balance the benefits that we do get from a new, very data-rich environment and the risks that come with the violation or the intrusion of the privacy of individuals, which is something that Kathy O'Neill, one of the protagonists in Coded Bias, talked a lot about, and she's written about in her book. And it's also something that Professors Park and Talhouk have worked on a lot in their own work. So on the one hand, it seems like there's a psychological reaction we have to our privacy being invaded. It's not really tied to any particular risk. It just feels creepy. It feels uncomfortable when our privacy is being invaded. But there are other risks, and sometimes those are tied to that creepiness, and sometimes they don't even elicit that creepiness at all. There are these risks that we don't even feel are happening to us. So I wanted to ask about what those particular real risks are, rather than the ones that feel psychologically creepy but might not actually carry that much harm. How about we first go with Professor Park on this, and then we can turn to Dr. Talhouk and talk about it in the specific context of health data, which she works on. But Professor Park, where do you see the real risks of privacy invasion and surveillance expanding with technology? and you're muted. Dr. Park, you're muted.
All right. You can hear me, right? Yeah, okay. So I can start with some very interesting paper recently published. So this was talking about this deep learning, deep models can memorize data. And so this is in light of how these emerging technologies can invade our privacy. So in this paper, this particular paper, they were talking about language models. If you input certain sentences, right, and that language model can complete the sentence. So auto completion, this kind of task, they look at it, and they had a lot of training data, and they trained the model. But then when they input certain words, certain sequence as a prefix, then this trained model can complete the sentence with high accuracy. So for instance, let's say there was one particular person. It was a very rare example in the training data, and the model can memorize these data points if they are rare. And if you say user A's social security number is, then the model can complete the social security number with high confidence. Things like that. This was a very alarming example in the whole field, and this was really unintended memorization. This was something that came to my mind when I first heard your question. Other risks are, there are a lot of other risks. For instance, people are publishing their data after anonymization, but there are ways to de-anonymize this anonymized data, and also people can use other like generative models to reconstruct certain attributes to the model, or they can also combine publicly available data sets and together with some published model that was trained with private data, combine these two knowledges, and then you can accurately identify whether a particular individual was in the training data, the private training data or not. So this is something called the membership inference attack. So there are many forms of attack methods that could be viewed as a privacy risks.
Okay, great. So riffing on that for a second, one of the things that I always maybe take false security in is this idea of privacy by obscurity, that yes, my data, my anonymous data may be vulnerable to people who'd be keen on finding things out about me, but I don't see why anybody would actually want to find anything out about me personally. I'm not an important person, and so I'm just one of millions of people in Canada. So why am I wrong about that? Why is that a false sense of security? Why should I actually care about the fact that me, just some Joe, has my data vulnerable? And anybody can weigh in on that. But maybe Dr. Park, you want to go first?
Because you as an individual might be maybe okay with, I don't know, revealing your sexual preference or things like this. Maybe you alone will be fine, but maybe there are a lot of other individuals who are not fine with it. And by combining these publicly available data sets, you can even like identify this kind of privacy sensitive information.
That's a good reason. Anybody else on that? Go ahead, Blaise.
Well, couple of quick notes. So either I'm obscure, nobody would care, or nothing to hide, nothing to fear, are that was John Major famously, and actually Eric Schmidt as well. Has given that one. They're both pretty specious. The two things that if we want to get very concrete, two issues here that apply. First, compromat. So the idea that one can hoard sort of large amounts of information that would be embarrassing or that could be used as blackmail material about large numbers of people, and keep that in store for whenever something is needed. whenever you need somebody to do something, that's not a hypothetical anymore. I mean, everybody's got compromat. The idea that oh, like young people nowadays, don't care about showing that they were getting high or getting drunk last night or whatever on their Instagram feed. I mean, actually, young people, modify their privacy settings more often than older people do, and are more careful about curating these things, with real Insta, fake Insta, etc., kind of stuff. The fact that more is change over time, that certain things are no longer as scary. It shifts around, right? So what is or isn't stigmatized shifts around. So, for example, being gay, less stigmatized now than it was 20 years ago. Cheating on your partner, actually, arguably more stigmatized according to Pew reports. There's always something, and finally, auto hacking is something that we should really be thinking about here. Part of the consequence of having machine learned models that can do coding at scale or hacking at scale, which is a consequence of large scale language models that can do code. It means that obscurity isn't necessarily a defense. One can small actors can deploy increasingly can deploy systems that will hack or compromise at scale. And then have exactly the kind of compromat repository that I was just talking about, that in a former generation might have required like several KGB or FBI or CIA agents, for that matter, as with Dr. King, working to gather the material, but then now can all be done sort of predictively or proactively within secure systems for massive numbers of people. It's sort of the flip side of mass surveillance.
Okay, well, that's pretty scary. So I will no longer take full security in that. Aline, so I want to stick with privacy, but I want to move to health related privacy, and picking up on some of the bias discussions that were happening in the coded bias films, and how certain groups are more vulnerable than others to some of this invasive technology. Are there certain groups that their health data is at more risk, or they would have greater consequences if their health data were to be discovered? Are there elements of bias that interplay with the health privacy issue?
So this is kind of a very interesting question, because as you alluded to in your intro, ethical AI is not just privacy, it's a lot of things, right? It's bias, it's explainability of models, it's trust, it's a bunch of things that kind of go into what constitutes ethical AI. And the right to privacy needs to be weighed with the right to benefit from scientific advances. And so when we think often about, oh, I don't want to reveal my ethnicity because then that sort of exposes me as a minority group, and then that could make me vulnerable. But at the same time, if you don't do that, then you're not making sure that you're inclusive. So it's a double-edged sword, right? So on the one hand, you cannot measure that you're not being inclusive if you don't track certain things. But on the other hand, you're potentially exposing someone's ethnicity. And I think, there are risks, and they're multifaceted and real. There are data security risks. Those are some of the biggest risks, actually, that we're faced in with healthcare, more so than privacy, I would say, at the time being, just because of the models, the AI algorithms have not permeated healthcare in the same way that they've permeated other facets of society yet, but they're on their way, obviously. But right now, cyber attacks, data hijacking, things like that are much more common in the healthcare setting. And as data is becoming more and more of a commodity, we are creating these honeypots, which are attracting all of the bad actors. And as Mijung explained, data privacy leaks also from the algorithm itself. So for example, someone could reverse engineer the models and reconstruct the data that was trained to develop these models. And then they take that data set and then they link it with another data set with identifiers. And then now I have identifiable data, which then could be used to stigmatize, if someone's HIV status becomes known to their colleagues, they could be denied access to insurance or whatever. This is maybe less of an issue in Canada, but more of an issue in the US, for example, health insurance. There are just so many things, not to mention that, who wants to have their data, their lives, their intimate lives being accessible to other people and be open book to other people. I mean, there is that need to privacy that needs to be sort of, that needs to be preserved, right? On some front, we have to have agency over our own privacy in our data and have the right to be anonymous. And I think this is what sort of creates this issue. And I think definitely the question of these vulnerable groups, yes, it's important that we protect them, but also important that we include them, right? So that's kind of, we protect them by including them in a way. And I think this is like a very interesting question. And I guess this is partly why there's a debate, is that the algorithms in of themselves, they're not inherently good or bad, just like a hammer isn't good or bad, right? You could use the hammer to build a house and that's a good thing, or you could use it to smash someone's head and that's a bad thing, right? So, and I think that's where the algorithms in of themselves, they're just as good as we've made them and we've tested them out to be. So for example, if I were to introduce a new tool like a chainsaw, for example, I have a responsibility to check to make sure that it's safe to operate. I have the responsibility to make sure that the person who's going to use it knows how to use it. They have an instruction manual. They know the limitations. It could be regulated. And I think the responsibility isn't just on the corporations, or isn't it just on the government. It needs to be at multiple levels of society, right? From the individual responsibility to the person that's putting out the algorithm's responsibility to the person that's regulating. So it needs to happen at every level before we're able to have these be part of everyday life, especially in healthcare. And another thing to note on here is that often when we hear AI, we often think of automation, right? We've often thinking of, some sort of algorithm that's kind of making these decisions on their own, and humans play no part in this. And I feel like that, at least in healthcare, and again, I know that that's not, equal across different aspects of society, but at least in healthcare, this may not be how these algorithms will be. That's not how they are currently being used. And it may not be a while before they're fully automated and there's no clinician that's administering these, and they're really being used as tools similar to lab tests, for example. Yes, I would not want my medical care to be determined by automatic thresholds of a lab test, right? I still want the human to look at the lab test and interpret the results. And that, I think, is something that, if we view AI in the context of healthcare as a supportive tool, as opposed to a prescriptive tool, I think our fear of what it might do will be lessened because, again, I think, and I'm not saying that it doesn't have the potential to be biased and to leak privacy and all that, and all of these things we need to put these algorithms through a battery of tests before we adopt them and implement them. But I think it's doable. It's not doable, and I think it would result in a greater good.
Okay, so one interesting thing here, I find the healthcare domain versus some other domains is that, at least in Canada, the use of algorithms in healthcare are more or less for the greater good. What's good for the healthcare system is also good for the individuals. Everybody's trying to make these algorithms as beneficial for everybody as possible. And that might be contrasted with some of the corporations that we might see, where the interests of the corporation might be misaligned with the interests of us as individuals. In other cases, the algorithm might actually be, the interests of the corporation might be aligned with the interests of the individual. A better algorithm would benefit both of us. In some situations, a better algorithm might be just better ways of a corporation exploiting us. So, Blaise, I want to turn to you here because you are our resident person in private industry. So you currently work for Google.
Our resident sellout, yes.
I wasn't going to say it. In the movie, so the main protagonist of Coded Bias, Joy Buolamwini, has I think been very, very media savvy. She's very good at capturing attention and using that to put pressure on these corporations with seemingly some effect. So in the Coded Bias, we talk about IBM, how they improved their facial recognition software to be better able to properly detect the faces of of women and darker faces. More recently as in a couple of days ago, we find that Facebook seems to have gone even further and just abandoned, under enormous pressure, their facial recognition software, deleting tons of their data. So how have different companies responded to these ethical issues being raised? Granting that you might have some professional loyalties here, but which ones have distinguished themselves as the most ethically responsive, and which ones seem to be sort of lagging behind on the ethical realm?
Well, I mean, you're putting me in the difficult position of not only, am I going to shill for my company, but like what shade am I going to throw on other companies, which is a tricky one. I will say a few things. I mean, the first will sound maybe a little bit braggy, but one of the only facial recognition engines that Joy's work didn't single out as performing poorly on Black people, and especially women of color, was Google's, which I was very happy to see happen because I was running the facial recognition team among a number of others at the time, and it was something that the lead of that team, Hartwig, Adam, and I had been focused on pretty intently from 2015 onward, from when we began working to make those things run on device. So the AI fairness issue with something like facial recognition if we just restrict this to does it work well on people of different categories, of different races, sexes, etc., is really straightforward to address. It's just a matter of making sure that you have balanced data sets. Even there's some pretty interesting questions about how one actually defines the demographics of interest. And that's not simple because, for instance, in social justice land, one hears terms like Latinx used, for instance, and there's a lot of rhetoric about, what kinds of terms are okay and not okay to use. There's a sort of terminological treadmill. There are legal constraints also as to what can be asked and what can't be asked. Aline alluded to some of those kinds of constraints. And all of that creates a sort of a minefield, both a social minefield, sort of a Twitter minefield, if you like, and also a legal minefield for doing the necessary sorts of balancing in data sets kind of work. I've seen a lot of use of euphemism in the process of trying to solve that, like, a person of color, for instance, is absolutely a euphemism. I ran a little, just personally, I ran a Mechanical Turk survey just a couple of weeks ago on 2,000 random Americans. And it had basically the one question Mechanical Turk survey. It just said, like, list all of the ways that you identify, one per line, free text. And out of those 2,000 people, not a single one identified as a person of color. The word color was used 3 times, twice by people saying, you might want to ask what color people are, by somebody who had misunderstood the question. And once somebody who said, yeah, I like the color green. The word Latinx was not used even once. There were quite a few people who identified as Latino or Latina or Hispanic, but Latinx is an invented word. It's not real. And if we're trying to to really define sets of people and look at the relative performance of an algorithm, whatever it is, AI based or otherwise, I think it's very important to begin with a completely ethnographic and self-identity focused sort of perspective, in which we're not trying to sort of define ontologies. Either neither companies nor governments, nor other entities should be trying to ontologize these things from above. They should emerge from the way people self-identify first and foremost. There have been lots of laws, about sort of preventing companies and governments from gathering databases of this sort of stuff for good reasons, that go back to what IBM did in the Holocaust, or what South Africa did under apartheid in creating, racial categories and gathering databases. And actually, it's been done in the U.S. as well with Japanese people, leading to databases that helped with the internment. There are technical ways of addressing this that actually excite me quite a lot, like using federated analytics. And I would like to talk a little bit more about federated learning, because I think this can address many, many interesting topics in the whole sort of AI ethics domain. But in a federated analytics sort of setting, you can have people on browsers or in their own devices, identify in whatever ways they would like, and then run analyses, get dashboards of how some model or something performs on sets of people, and get those results without ever having a database that either that Google could be forced to cough up, say to the government or what have you later on. So there are ways, technically, legally, and so on, to be able to get some of these sorts of outcomes that will, that let one circumvent some of the problems that Aline was talking about. In a lot of these cases, also with surveillance, it's really power imbalances that are at the core of a lot of the problems. When you that's true of predictive policing, and it's true of micro targeting, and it's true a lot of the other things that Marc-Antoine raised as specific, sort of loci of problems in AI at the beginning. So we should always be looking at power and the potential for social control first and foremost. I think that often we end up blaming algorithms for things when in fact it really is about power. For me, algorithms for justice are actually a huge problem, whether they're automated and enacted by machine, or they are enacted by people. I find the idea that we have ideas about drugs being bad, we have ideas about like larger amounts being worse than small amounts, and we have ideas about moving drugs across state borders in the US as being a big deal. So you end up with these absurd laws like, if it's cocaine and it's more than 5 grams and it crosses a state border, then 3 strikes, you're out. And the reality is, like, I don't care whether it's a machine or a human that that carries out the mechanics of that judgment. It's the result. The result is tons of injustices that don't accord with common sense or psychologically based ideas about ethics and morals, and instead are exercises of power that are both arbitrary and also highly noisy, by the way. This is also, I have more to say about that, but maybe I'll put a bookmark in that aspect. I actually think that that neural nets and modern forms of AI can do a lot better than either algorithms or human judgment when it comes to a lot of these sorts of things. But it requires that we take a very different approach from just taking a bunch of biased judgments by human judges, feeding them in and saying, oh, we've just automated the process, or making up a bunch of arbitrary rules that have come about through some process, whatever it is, and then enacting those either machinically or through humans. Sorry, I know I've drifted quite far away from your original question.
No, that's really interesting, and there's a whole bunch of threads there.
There's lots here, yeah.
I want to pick up on, I want to pick up on one just because it kind of goes into psychology a little bit, which is my area of expertise, as well as some issues that I've been paying attention to a lot. So you mentioned, I guess, Twitter world, social justice world. It occurs to me, I'm on Twitter a lot, more than I should be. And
I'm sorry to hear.
I know. I'm trying to cut down. It strikes me that the population on Twitter, actually we know this, is a very small and very unrepresentative slice of even the Canadian and American population, let alone the population of the world.
Yes.
It also, and picking up on your point about power, the people who seem to be exerting top-down influence on a lot of these algorithms, a lot of the technology that's put forward, seem to belong as well to this very unrepresentative slice of the world, even though the rest of the world is going to be exposed to these algorithms and is going to have these algorithms have power over their lives.
Yes.
People like us, academics and people in the tech industry, seem to have, as a result, hugely disproportionate power over the lives of people. And the ethics that we decide to be the appropriate ones, as a result, get imposed on the rest of the world. I want to read you a quote from a data journalist in the Coded Bias movie. This is Meredith Broussard, and she said, "The machine was simply replicating the world as it exists. They're not making decisions that are ethical. If we use machine learning models to replicate the world as it is, we're not actually going to make social progress." And that's a great point. these just reflect the world as it is. We have ideals about the way the world should be. But the issue is it's our ideals. It's the ideals of this group that's imposing them on the rest of the world. How do we balance this sort of cultural imperialism about our own ethical positions when it's not going to be the same people with the same ideologies, with the same morals who are going to be exposed to those algorithms? This is open for everybody here.
I don't want to. This is such a broad topic. I certainly don't want to hog it, and I'm sure that others will have lots of ideas about this too. But this is something that I have been thinking about a lot recently, and I actually think that we have wonderful techniques that have only become possible just in the past 2 or 3 years to address exactly what you're talking about that did not exist before, and frankly. A lot of the critique of AI that that I've seen leveled. I'm thinking, for example, of Algorithms of Oppression, but also of Kate Crawford's book, Anatomy of AI, and a number of others. Feel like they're actually taking aim at sort of 2015's techniques and have not fully accounted for what has happened since 2017, which opens up really new and interesting possibilities. So first of all, if we take something like a judgment, a positive or a negative judgment, whatever it is. I mean, let's actually take an example of a judgment that needs to happen at such a scale and with such low latency that we can't have it be done by humans. So I'm not talking about accepting a paper in a journal, but for example, about whether to surface a notification or not. So we can't have humans doing that because if the volume is too high. There's no economics that could possibly make it work, and you want such things to be universally accessible. You don't want to end up in a, Neil Stephenson talked a bit in his last book, Fall, about a world in which the privileged have armies of kind of curators, curating their news feeds or whatever. That's not a world that we want. So these are cases where you need something machinic to be doing the work. So the question is, what values are informing that? And if we doubt that the values informing something like newsfeed ranking are important, well, obviously a lot of the political polarization, the extremization, the lack of grounding in reality and so on that we've started to see happen in the last few years is a function of the right values not being imbued into exactly that system. So it's massively consequential, both individually and socially. So what values do we imbue into those things? Well, if we take a kind of hegemonic point of view, then we might say, a few engineers in Silicon Valley or Twitterati or whatever are going to make up some rules or come up with reams of training examples and make a supervised learning system that is going to replicate that. That's not inspectable. It's not transparent. The amount of examples that you have to put in mean that you need to aggregate over this whole still narrow subset of humanity, and you end up replicating whatever the biases are of that set of people. So that's not great. Rules are not great either, because if you make a simple set of rules that will do this, they will also have kind of feedback effects, often that are quite hard to predict. So like a very simple rule is maximize engagement, on YouTube or something like this, and the results of optimizing for that we know, right? We know where that goes. So here's a much more interesting idea. Begin by training what is now sometimes getting called a foundation model, which is use unsupervised learning to train holistically, to train without labels on vast amounts of public data, say like big chunk of the web. Now I have seen, well, before I go to the critiques, once you've trained such a foundation model, then it learns how to generalize, and it becomes a few-shot learner. And what that means is that very small amounts of supervised data can specialize it to do any task, and can also, by the way, imbue it with values. And this is a very interesting and new result that hasn't been written enough about yet. But you can think about an injunction like don't be anti-Semitic, for instance, as nothing more than a supervised learning task. Just like you can tell if something is anti-Semitic because you kind of know it when you hear it, in just the same way that you know it when you see it with respect to a bike or porn, right? Which are both, so in computer vision, like these problems were solved with convolutional neural nets and things like them, 10 years ago. And we're now able to solve a lot of these kinds of things with language using these new kinds of models. So there's been a lot of talk about trying to curate or limit the amount of unsupervised data, or what kind of unsupervised data is used to train the foundation models. Oh, it's too big. You can't curate those things carefully enough. What if toxic content gets in? Is that going to bias things? And so there have been calls for for us to try and think about smaller models that that are going to be more careful about what goes into the unsupervised model. I think that that's completely wrong-headed. You cannot actually tell a model with fine-tuning, with supervised learning, not to be anti-Semitic if it doesn't know what anti-Semitic is. It's actually very helpful if the unsupervised model has incorporated the statistics of the Daily Stormer, as well as social justice texts or whatever. And in fact, if one tries to clean the unsupervised stuff, one ends up excluding minority voices, not only extreme anti-Semites, but also, I think of texts like the autobiography of D. Hunter, who is a half Scottish, half Gypsy, very poor, working class, only learned how to read and write in his 20s. His short biography, it's from 2018, is a wonderful book, and it's very evocative, very humanist. Very essential reading, I think, for understanding an entire social class of people in Britain who are radically underrepresented. Even the word chav is not one that most people know. And it has a content warning from the publisher saying, like, this book contains, accounts of rape, sexual violence, police brutality, transphobia, every other imaginable awful thing is in there, right? But of course, one wants an unsupervised model to take in such things. The idea that of garbage in, garbage out, that is true if one is just trying to replicate judgments, is not true of learning representations. Representations should be learned from everything, because that's exactly what lets you, push off of certain ideas or toward other ones. You need the representation to be there in order for any of the supervision to make sense, in order for the generalization to work in the supervised stage. Now, the thing about the supervised stage that's so interesting is that it requires now only a small amount of data. So, where if you suppose that you were using the old-fashioned approaches to train a model to recognize, whether an experience of biting into a piece of fruit is good or bad, thumbs up, thumbs down. If you were training that from scratch, you need millions of examples of sentences about biting into fruit. But if it's one of these models that has learned in an unsupervised way from everything, then a few dozen examples will do. And it will already know about Russian literature. It'll already know about irony. It'll already know about about the different kinds of moths and larvae that might occur in the fruit, and so on and so forth. And what that means is that you can then have a very limited and very inspectable and curatable number of principles and case law, examples of these things that can vary across populations. You can say, well, here are some core principles, here are some ones that are going to represent different populations, and it's a manageable enough amount of data that you don't have to be hegemonic. You don't have to think about a singular set of principles that are going to apply to everybody. And you can take some of the same approaches that I talked about with respect to representation in, say, face recognition models to make different versions of a system that will make judgments relative to the values of different sets of people. Sorry, that was long, but that's what's exciting me now.
A lot of food for thought in there. That's really great. Aline, you wanted to jump in there.
Yeah, I wanted to say, so here, it's very important. Again, I could only speak of healthcare because that's the domain expertise that I have, but often in healthcare, we anchor our modeling to something, right? We're trying to predict a gold standard and we're anchored to that gold standard. Now we're evaluating our model relative to that gold standard, how close we're getting to it. And we are able to set up benchmarks to make sure that we test, okay, is my model working on all, here are the things that I care about. And the documentary actually alluded to that, right? Like baking in our values. So say I care about not discriminating racially. So then I say, okay, is my model able to predict equally well for all the races? And if it's not, then I go back and get more training examples, right? Because you're benchmarking against something. And I think we generally in healthcare tend to shy away from these like purely unsupervised models that are not tied into some sort of biological mechanism or some feature that we could see what it's doing, right? Like, again, I think one of the biggest differentiators between healthcare AI and the rest of the AI that's permeated society is the fact that in healthcare, you need to be able to explain things, right? And you need to be able to understand how you're making these decisions. And I cannot have a black box model that's sort of directing care without having some sort of level of control, at least not at the moment. And so I think a lot of these these anchors help in the healthcare setting to make sure that you can benchmark based on, say, racial factors, or based on socioeconomic class, or based on, background, or based on whatever it is that Western value that you want to make sure that you bake into your model, right? So you can do that, and I think it's not as innovative as new discovery, but the question of implementing AI in practice and evaluating AI in practice, this is such an important topic, and it's so understudied. And I feel like that is definitely, there's a lot of room here, right?
I don't disagree. If I could just respond quickly, I don't disagree with what you just said with respect to how to test those models and the need for fairness. I mean, this is very much in keeping with what I spoke about with respect to face recognition models in the beginning of my comments. My statement about unsupervised learning as a foundation is not incompatible with what you just said. With respect to X-rays, for instance, what you end up with in any scenario that we just of the kind that I'm describing here is, well, is it a black box? Yes, in the sense that it's not a set of rules. It's something that, say, looks like a convolutional net that takes in an X-ray image and puts out perhaps a diagnosis. You need to be able to test that on people of different demographics and test that against clinical ground truth and see that there aren't racial disparities and so on, in order to know that you have a working system that is measuring what you think, and that it doesn't and that it's not unfair with respect to how it's doing the diagnosis. My only point about unsupervised learning is that if you begin by feeding a ton of different of random X-rays in that don't even have a diagnosis, and the system can learn representations of how to see X-rays in an unsupervised way, and you then follow that up with the supervision that says, okay, now I want you to make such and such judgment with X-rays, you will often get a better result than if you start only with the supervised learning stage. Now, you still can have representation biases. So, if all of the pre-trained data was from white people, then there may be something, right, about features that are present in black X-rays that are not sufficiently sampled in order for the supervised stage to do its job well, which you will then see when you do those diagnostics, right, using the supervised set. And that's why I'm arguing also for the most holistic possible, the largest possible data sets to be used for the unsupervised stuff. But it doesn't prevent you from doing any of the kind of fairness work that you're talking about when you actually specialize a model, when you use supervised learning to train it to do a specific task.
All right, Marc-Antoine or Mijung, either of you guys want to jump in on that, or I can move on to something else? I guess one of the reasons why I think that this issue is important, that the sort of ethics that bleed out of the technology need to be aligned to the local population, is that ultimately the local population is the one that decides whether this technology is going to be accepted or rejected. And that can be done for I guess, corporate technology, that can be done by choosing not to buy it. For public technology, that can be voting out the bums who decided to allow it, or electing some sort of Luddite candidate who says no algorithms in the public sphere. We're gonna remove algorithms from healthcare and criminal sentencing and all this kind of stuff. As a result, we need to kind of and this is again bringing it back to my field of psychology. We need to have it psychologically aligned. We need the people to accept the technology. In psychology, one of my favorite papers in recent papers in AI and medical diagnoses, this was published in Nature Human Behavior a few months ago. It showed that one of the reasons people tend to reject the use of AI or prefer the use of humans in making medical diagnoses is because they feel that a human empathizes better. They can understand the human concerns more, and they can understand aspects of what's personally, idiosyncratically going wrong with me than would an AI. But when you then reveal to them, well, actually, when you ask them, well, how does a human do that? Then they realize their actual ignorance, and they realize that they had this inflated view of what humans are able to do, recognizing that maybe there's not such an imbalance between humans and AI, or not at least an advantage for the humans, and they become more comfortable with AI. So, Aline, I actually wanted to follow up with you on this, but I'm again open to others jumping in on it. How do you see where do people's distrust of the use of these types of technologies in medicine, where do they come from? And how do we reduce those? How do we reduce that distrust and get people to be willing to accept things which might scare them away initially?
So again, and I think here in medicine, when we go approach our patients to consent to participate in research studies, often patients are very benevolent. Like they are surprised when they know that we're not using their data in research. And so they are very trustful. They just want to be made aware, right? Like they want to be made aware, oh, I'm going to be using your data here. You're going to be participating in a study. And I think here the views will differ depending on whether you're in Canada or you're in the US. So for example, in Canada, often there's a great trust with academics, with government, and there's distrust with corporations. It's the opposite is true actually in the US based on what studies show. But again, I think going back to this is to realize that on some levels, maybe patients don't know necessarily what are the potential risks. They don't know to which extent whether like they trust you in preserving their privacy. They trust you in doing whatever you need to do to make sure that they're protected, and it ends there. But they're not informed on the level of where, how publishing the model that's where their data was used to training could potentially re-identify them and could cause them this potential harm. And we don't talk about it yet in our consent forms and whatnot, just because we don't even know how likely that is. And I think recently in one of my research projects, that's what we've done. We wanted to quantify the degree to which this data leaking in models happens currently, right? Like, what do we observe in our health institutions? How often has this been reported? And the answer is almost never, right? Like every time there's a privacy issue or a security issue, it's often a security issue. Someone sent the wrong email to the wrong person, a fax was sent, or there was a cyber attack or something like that. It's never caused by the model. But that's not to say that it's not going to happen, but I think it may. And I think if it does, then you need to have a measured response. Like you cannot just sort of say, oh, I'm not going to take any risk and I'm not going to share any data because something may happen. If we all went by this, nobody would ever leave their houses, nobody would drive a car, nobody would take a plane anywhere, because there is always a risk. You weigh out the benefits and the risks and you say, okay, I'm going to participate in this research study because the good that comes out of this is much greater than the potential of somebody relinking my data or something. That's just not so likely to happen. And so it's a proportionate response that happens, and people make these choices. And oftentimes what we see is whenever we go ask patients for permissions to use their data, and we tell them that we're doing everything we can to preserve their privacy and to make sure that their data is held in confidence, and we're sharing it in a very ethical way, they're often happy to give it. I think maybe down the road, as models or algorithms start interfering with care, or maybe directing care, there could be more distrust that could arise out of lack of transparency, perhaps, or that could happen. I don't think we're there yet, though, and in healthcare. That does not mean that it may not happen, but we're not there yet.
It's interesting that you mentioned the Canadian-US difference there. I think to some degree, Canadians trust their public institutions more than Americans do. And that high-level trust, I think, maybe translates down to being able to trust anything that's being recommended to them. I mean, one of the concerns I have, I think, is that even this discussion has exceeded my level, and I'm in this industry a little bit, to expect that the public is going to understand how to balance these different risks and benefits, and to understand, well, what am I giving up with this privacy issue, and what benefit am I getting from the use of my data in the medical care system is unreasonable, not just because maybe they wouldn't have the education to understand it, but also because even if everybody could understand it, the amount of effort and time spent to get them to understand is probably not a good use of their time, right? We kind of divide that labor. We have experts learning that kind of stuff, and then we rely on those experts to give us some guidance on it, so long as the experts are trusted. And I guess that brings me to this issue of transparency and explainability. So to what degree, and maybe Marc-Antoine, I'll move to you for this, because I know you've talked about explainability both at the algorithmic level, so the explainability that the engineers themselves don't understand, as well as maybe the engineers do understand it, but nobody else is going to be able to understand it as well. In the case of the latter one, I'd like to get your thoughts and anybody else's thoughts on to what degree do people need to be able to understand, the lay people need to be able to understand what's going on in this technology. And then with regard to the former, how important is it for the engineers to be able to peek inside these black boxes themselves?
Well, you don't have to understand how an engine works to drive a car. And this applies to AI in everyday life. Now, obviously, well, we would like to be able to understand all the steps of an algorithm, even a deep learning algorithm. And we would like to be able to explain the results as if we were doing the calculation ourselves. This is what we would like to be able. But we have created, and it was the beginning of my remarks, we have created algorithms to think for us, accepting to be blind ourselves. And as you mentioned, we cannot always understand and explain human decisions. Why? Because reason cannot be isolated from emotions, desires, our body, living body. So we have to accept and put up with our inability to understand either human decisions and algorithmic decisions. Now, it's not the end of the story. Maybe you know, I initiated the project of the Montreal Declaration for Responsible Use of AI. It was now almost 4 years ago. And when I drafted the declaration, I was very careful, and it was in line with Yoshua Bengio and other AI researchers, Joël Pinault, François Laviolette, etc. I was very careful not to use the term explicability or explainability. Okay, why? Because, well, the AI researchers was telling me, well, we cannot understand exactly how it works. Okay, I accept that. Well, I accept. For the moment, I accept that fact. And on the other hand, you have people who want to understand exactly how it works. Not in general, not the overall functioning of the algorithm, but, you know, dive in the algorithm and understand each step of the calculation. Now, I didn't use explainability, and I preferred to use other words that I think are more powerful and more meaningful to lay people. And lay people includes AI researchers, because lay people are citizens, are people living in a shared territory, in a shared society. So at some point, even AI researchers are lay people. And the other words were intelligibility and justifiability. The capacity to make a decision just intelligible for people who ask not exactly how the algorithm come up with the decision, but what are the overall criteria of its decision, if we can say that an algorithm takes decisions. And we have to be able, especially developers and deployers, we have to be able to justify the decisions taken by an algorithm. So the responsibility and the blame is not on the algorithm, it's on the humans. And we don't know exactly how it works, how the algorithm works, but why we use it, how we use it in a complex social system where an algorithm is part of a more, well, broader decision-making process, okay? So even if explainability is technically feasible, and I won't go on this battleground, is it feasible or not? Actually, I don't know. Some say it's not, some others say, well, there is no such thing as a black box. At some point, we know how it works. So I'm totally agnostic about this question, but even if we could explain, well, the decision taken by an algorithm, what is crucial is to justify the results of its use in terms of goals for which the algorithm was designed and deployed. So if the machine produces results that do not meet the intended goals, well, we must hold the developers accountable, and the deployers should stop using the algorithm. Sometimes the end user should stop using it. And I would like just to add one more thing about explainability. I think.
Can I jump in there?
Yes.
I want to just get some clarity on what you're suggesting here, which we might be able to do with this concrete example, which is this example of Twitter. So I want to see, a week and a half ago, I think, as you know, Twitter released the results of this internal audit that it's been doing for several months about its algorithm, and it found this fact that for whatever reason, and they admitted to not understanding the reason behind why the algorithm did this, it amplified right-wing political voices. So people identified as right-wing and right-leaning media outlets more than it did left-wing media outlets. And it admitted this. It said, we don't know why this is happening, but it's happening. Here are some ideas. Anyways, in your estimation of, given that, okay, we might not have to understand the intricacies of the algorithm, but we want to hold the outcomes to be justifiable. Now, what do we do with that? Do we try to fix the algorithm? Do we try to tweak it, even though we don't know how it's going to change? Or do we give up on Twitter? It seems like, despite the fact that it might be amplifying right-wing voices more, the right wing already sort of hates Twitter. Well, everybody already sort of hates Twitter. So how do we deal with this? But people keep using it. So how do we deal with a concrete situation like that?
Well, I think this is the idea. If the algorithm doesn't perform as intended, well, we have to tweak it. And if the developers cannot, redress harms and revise their algorithm, well, they should just, you know, ditch it and ditch them and not use them. So this is why I think impact assessments are so important in AI governance. I'm mainly concerned with AI governance. And I think we should use impact assessments to spot issues with algorithms, even if we don't exactly understand how it works or how the outcomes have been produced by the algorithm. So impact assessment is key to the governance of AI. I think this is the main idea.
Okay, so this is great. Aline and then Blaise, you both wanted to weigh in on this. Aline, why don't you go first?
Yeah, so on the issue of governance, and I think that's the key thing, right? So you want to have multiple stakeholders that are in the room when you're discussing governance. So, you know, you're going to have the end user, you're going to have the clinical practitioner, and again, I'm going back to the health setting. You're going to have the data stewards, or, you know, the hospital representative, the policymaker. They all need to be in the room as you discuss this. And the solution is really a socio-ethical and socio-technical, actually, solution, because on the one hand, you want to set in the rules and regulations and how you're going to access the data and how is the data going to be released and who can do what and what are the benchmarks that need to be, you know, what are the different hoops that an algorithm must jump before it can be released for use and sort of stamped as valid for use. So that is something that is going to be determined with multiple stakeholders from multiple backgrounds. And then you have the innovations, the technical innovations, the federated learning, the differential privacy, synthetic data, right? Like all of these things could come and they could support this, but you cannot have only one aspect and not the other. You need both. It needs to be a marriage. So on the one hand, you need to have privacy by design and by default. On the other hand, you need to make sure that that is balanced out with accurate models that can perform in practice, right? And so that balance needs to be threaded really carefully and then decided on jointly with multiple stakeholders. That was my comment.
Great, Blaise.
Aline, I agree with everything you just said. I also I found myself disagreeing with a number of the points that you were making, Marc-Antoine, you know, for a few reasons. One is that I guess goes back to this word algorithm, which I've come to kind of hate in its modern usage. People, you know, tend to use algorithm for anything that a computer does, although the reality is that neural nets, you know, I mean, if you write down a neural net as an algorithm, it fits in a tweet more or less. I mean, it's just a few nested loops, you know, of multiplications and additions. That doesn't tell you anything, of course, about what is really going on. There are no, you know, nouns and verbs, you know, or named variables or whatever in that. I mean, when you look at an algorithm in a scientific paper, you know, you get the little description, you know, of like, you know, count up the number of these, you know, and if they exceed that, then, you know, go back to step 2. And that's an algorithm. And you can make proofs about algorithms and you can understand, you know, the decision process of an algorithm, but that doesn't mean that they're good for everything. You know, we tried for you know, 50 years to make an algorithm that could tell whether there was a bicycle or not in a picture, and it turns out you can't do it. You know, you can say, well, like use such and such rules to try and find circles. The circles represent wheels. A bicycle is something that has 2 wheels and has a handle, you know, but of course, like the reality is, like, you know, convolutional net to train to see, you know, to recognize bicycles the way we do, you know, works much better than any of those rule-based systems and is not in the same sense explainable any more than your visual system is explainable. So like where we get off saying that we're explainable, you know, our own brains are explainable, I have no idea. I think what we mean when we say that is that we can tell each other stories. And there are lots of psychology studies that illustrate how we make up the stories post hoc more often than not. And you know, we have language models that can make up stories as well, you know, and maybe can even do a better job. making that story really relate to, to the sort of the internal reasoning of the thing, perhaps. But for me, transparency is much less about making up stories or about trying to write things down as algorithms that are inherently not algorithms, but that are, you know it when you see it variety. And they're much more about questions like, who has what information? Where's the power imbalance in something? What training data was used? And and that's why small amounts of training data can be much more transparent than large amounts of training data, because they can actually be digested, and understood by by a person in a finite amount of time. It's why for me, like a big transparency issue, for instance, is if a digital assistant is sending all of my speech to a server for analysis, and the company sees all of that, that's important for me to understand, and like, does it get retained, and what is actually, can it be coughed up or not? When companies say things like, well, there's a hot word detector, it's running locally, but if something passes that, then all of the speech goes to the data. It's like, this is where people get very confused about, like, well, okay, so who knows what I'm saying and who doesn't? Does it conform with my common sense ideas about sociality, about actors? Right? For me, explanation is much more about these questions of power imbalance, of what's going on, of what the motives are, of what's being optimized, than they are about the mechanics of how certain judgment calls, about, say, the presence or absence of a bicycle or of anti-Semitism, or whatever, get made, which are I think fundamentally they're not linguistic. They're not things that are really all that subject to explanation. And finally, yeah, please.
I just wondered where we disagree exactly, because this is my point. We don't have to go into we don't have to use this concept of explainability to justify the use of AI system. If you prefer AI systems rather than algorithms, I'm perfectly fine with it. I think it's a more precise,
That's totally fine, and perhaps we do agree on these points.
Okay.
I may be presuming.
No, okay. So I'm sorry for interrupting you.
No, not at all. I mean, I think the point about goals mattering, right, is fundamental. There is one other place where I was not sure. You were talking about outcomes, and you and Aline had a bit of a back and forth about this, and I do just want to point out that in a complex socio-technical system of the sort that Aline was talking about, there are many unintended consequences. They're almost a default, and so transparency about what is being optimized for in a piece of something that is larger, that involves all of society, is super important. But it doesn't give you consequentialism. It doesn't give you the ability to understand what the results are. I don't think anybody could have predicted when various social media platforms optimized for engagement, for instance, that would result in political polarization. I mean, maybe some very clever person saw that it would go that way. I don't know, but I certainly don't think I could have predicted that. Now that we understand that, it gives us like lots of questions about, okay, so what else, right, can those ranking algorithms do, right, that will perhaps result in a different thing? But it's actually an experimental question. I mean, you're looking at a complex dynamical system, and you at some level you can't really know what the outcomes are going to be until you have tried. So being responsive, right, looking out for those problems as they emerge and being responsive to them is important. But we can't take I think that it's dangerous to go to a strictly consequentialist system of blame, about a system when we're dealing with mixtures of actors, of human actors, of technical systems, of AIs, that result in all kinds of things. And this is also why I was also not particularly happy with the way people jumped on Facebook for conducting experiments, on live people. I mean, everything we're doing is a live experiment, right? In some sense, like a lot of this has not been tried before. What we need to hold companies and governments and so on to account for is not being responsive when we see that something is going off the rails.
Go ahead. Go ahead.
So one thing that the documentary alluded on is that that was the only way that we knew about this experiment at Facebook was because the company reported it. This sort of raises an important question: should companies be reporting all of their experiments, right?
Well, it seemed with Facebook that initially, my first position was at the University of Oregon, and one of the grad students there went on he was the first author on that paper about manipulating people's emotions. And that paper was published in the Proceedings of the National Academy of Sciences. It was, I think, the most cited paper in that journal, which is a very good journal of that year. And it seemed like Facebook learned their lesson from that, which is we should not be advertising that we're doing this, and then continued to conduct all the experiments, but kept them under wraps. And then we recently learned about all these experiments that they did, and then seemed not to respond to. So in that case, I guess maybe then some blame is appropriate for their response rather than for actually.
Yeah, no, I'm not saying don't blame Facebook. I'm saying like we blame Facebook for the wrong thing, in effect. Exactly.
One thing that I did note, and I wanted to make sure we shoehorned this into the conversation somehow before we finished up, which seemed like an area of agreement between Marc-Antoine and Blaise, is this idea that yes, maybe algorithms or AI systems are hard to understand, but so are human beings, and that we are maybe even more black boxes than these algorithms. I'm trying to remember where I was going with this. So on the context of bias and diversity, one of the most dispiriting things that has come out of my field for this, and I think that not enough people know about this, is all these attempts to do these diversity training systems, which organizations spend literally
backfire.
Sometimes they backfire. Usually they have no effect. There's absolutely no evidence that they actually do any good for the purpose of actually correcting bias. They might do good in terms of PR, but in terms of correcting bias, they don't do any good because humans are complex, and our tools for manipulating humans are not great. And that's my field's fault. We're continuing to work on that. It seems like the algorithms might be more, or the AI systems might be more tractable loci for actually fixing some of these issues. So in the last 5 minutes of this, I was hoping maybe you guys could tell us some of the low-hanging fruit that we could work on right now for extracting bias or correcting bias or making these AI systems less damaging in terms of that domain in our world. And I know that's a big question. But
I feel like I probably have already answered. I mean, I feel like federated learning and federated analytics are really important here. Unsupervised learning and the ability to curate small, to sort of state principles and case law, if you like, meaning examples in a compact and legible way, and to be able to iterate that and test them against self-identified subpopulations in the ways that we just talked about. That combination of ideas seems powerful to me for addressing this.
Great. Mijung, do you have any ideas for this? Any area that you are focusing on or you've heard of people focusing on that might be particularly useful?
I agree with him. Basically, to remove bias from a trained model, you need more data to remove that bias. And federated learning would be a good way to have more data from different groups of people. So like one concern is, okay, the federated learning also has a lot of problems with privacy. What do you do? And there are a lot of work on, privatizing local data or sharing models trained on a local data in a privacy preserving way. So I think we are going in the right direction.
Well, that's great. I think that last point, it seems to me that the pressure for these topics is getting more and more intense at the same time as the technology is getting more and more powerful. I can't tell from my perspective as a outsider, as a novice looking in at this stuff, whether we are going in the right direction, whether things are getting better or whether things are getting worse. A lot of the a lot of the books that are published on this, Kathy O'Neill's book, etc., seem quite alarmist. But the Coded Bias movie ended with some sort of hopeful, inspiring examples of companies being responsive or governments eliminating facial recognition software.
I did want to put a quick note on this. I've been really bothered by a lot of the, both techno-optimism and techno-pessimism that I see happening. It's really bothersome on the one hand for me to see, Elon Musk and pals, talking about killer robots, even while they, go ahead and develop all of those kinds of things in their own companies, of course. But it's a lot of it's weird how it's all like old white silverbacks, like white men with with a lot to lose who are paranoid in these ways. That's kind of interesting. And then on the other hand, a lot of very social justice oriented and very anti-tech, sort of tech abolitionist voices, really, saying, like this is all horrible, it's all bad, and seeming to take, to be taking aim really at the whole idea of progress, both technical progress and social progress, which they claim is just not, are both illusions, neither artificial nor intelligent, which seems like it's such a difficult thing to wrap my head around. Like, how can we really look at the history of technology and of progress, of social progress over the past, 10,000 years, and conclude that, that we're moving backwards? We're not moving backwards. And this sense of hopelessness, both from conservatives and from progressives, is really something that I'm feeling an increasing urgency to push back against, because I do feel like there are things that we can do, and there is progress being made in all of these different quarters.
I think being aware of these issues is very important, but you cannot be driven by fear, right? Like we should not fear technology, because there is a very big ethical issue with not following technology, right? Like if I have an algorithm that could help me triage patients into the ER, it would be unethical not to use
exactly.
So I feel like we have to tread cautiously, of course, and be aware and take that into account, but we cannot adopt like a fear mongering with technology.
I think that ends right where Marc-Antoine began, which is this idea that we shouldn't demonize the technology. We should recognize that there are trade-offs involved and try to maximize the positives. Marc-Antoine, why don't you take the last word there then?
Well, actually, I think that's we tend to think that technology and AI especially could help solve social and political issues. So, of course, AI is very powerful to perform a wide variety of tasks, but I don't think we should rely on technology and even AI to solve our problems, our social issues. So I hear what Blaise said about pessimism and optimism, and I think we are experiencing in the 21st century, well, the deceptive scientific optimism of the 18th and 19th centuries. At that time, it was thought that medicine and science would bring happiness to humans. Okay, blind people can recover sight, and so, well, happiness is at your door. So, well, science is in itself not good or bad. It could be good, it could be bad, it could bring health, but it could also bring nuclear bombs. So in conclusion, what I would like to say is, if you want, if you want to fix the machine because you think that the machine, the technology is ill-used, misused, well, just fix the humans before, fix society first.
Well, that sounds easy. All right. No, thank you so much, everybody, for that. I think that there's great that there's so many different perspectives coming from the different fields that you all represent. It's really great learning from you.